concrete industry is focused on reducing its emissions, with the aim to produce net zero concrete by 2050, but have been making efforts to improve environmental performance and implement sustainable practices for decades of operations in the province of British Columbia and across Canada. While there are many actions underway to reduce the carbon intensity of our raw materials or improve the energy efficiency of our production facilities, there is a limit to how ready-mix or precast concrete producers can reduce the carbon footprint of concrete without support from other stakeholders in a project's lifecycle. Ultimately, the responsibility for lower carbon concrete is shared between the concrete producer, the general contractor, and the design engineer specifying the concrete to meet the needs of a given application. One of the most significant ways a design engineer can contribute towards lower carbon concrete is through the use of performance-based specifications as opposed to prescriptive specifications that can be restrictive and run counter to a project's embodied carbon objectives. Performance-based standards and specifications are focused on the end result, measured and validated by standard test methods, while prescriptive specifications detail specific means and methods as to how the intended result ought to be achieved. In concrete's case, this often relates to minimum cement content requirements or maximum substitution rates for supplementary cementitious materials. By placing these limitations on a concrete producer, there are fewer carbon reduction alternatives available, which prohibit deeper, more impactful carbon reductions from being realized. By concentrating more on strength and exposure class conditions with performance-based specifications, the concrete producer has more flexibility in preparing lower carbon concrete mixes without negatively impacting the quality of the final product. A recent example of a transition from prescriptive specifications to performance-based specifications comes from the BC Ministry of Transportation and Infrastructure, who in 2022 adjusted the requirements for precast concrete highway barriers in the province.
Hi, I'm Todd Skelton, Quality Control Manager at Sure Cement Structures. We have a concrete plant on site, plus our own concrete production for precast. We do a variety of concrete precast products. Behind us we have our concrete barrier production facility. We produce approximately 3,000 barriers per year. It just depends on the orders we have through MOTI and how many get hit by vehicles during the year up and down the Island Highway. Our concrete barriers are produced with the new performance-based specification. So in our concrete barriers, we put in cement and we've started using slag now as our supplementary materials. By shifting from a prescriptive to a performance-based, we are able to better optimize our concrete mixes to give us the best product possible and reduce the amount of the cement content because we're not having to meet that minimum cement content that was set maybe 10 or 15 years ago, allowing us to reduce our greenhouse gas emissions by about 22%, 46 kgs per barrier. It works out to approximately 138,000 kgs, which is equivalent to an SUV driving around the world 22 times. And we've made, to me, a far superior, better product for the environment and for the barriers. This is where we produce all our concrete barriers, and we do production every day. The concrete ready-mix truck brings the concrete over, gets tested. We start dumping it into the molds. We produce them inside a building so we can keep the concrete barriers at a specified temperature, keeps the rain and the wind and the sun off the concrete during the production. And then after the concrete is finished, then they put tarps over it, and then we apply heat to it so we can get up to our stripping strength in the morning. We can produce up to 60 barriers per day. The concrete takes approximately 14 hours. We get an email from our software, tells us when the concrete has reached its strength. So the guys in the morning know that they can automatically start stripping. They use a rolling machine to roll the barriers out. And then they use the forklift to pick the barriers up and transport them outside. And then they pick the barrier form up, and then it gets cleaned and oiled and ready for barrier production. We want to be the best we can be for the environment, and we're looking at other products that we can use this performance-based specification on to reduce the greenhouse gas emissions. We started using the new concrete barrier mix on our bike lanes because it follows an MOTI specification also. Behind us we have our concrete bike lane barriers. This is a great example of trickle-down effect with having a performance-based specification. Before it was based on the MOTI specification of 320 cement, so now by having the performance-based spec for bike lane barriers, these are 22% less greenhouse gas emission. for the majority of municipal concrete, be it bike lane barriers, regular roadside barriers, anything usually to do with concrete in municipalities, they fall back onto the MOTI specifications. And the municipalities copy and paste that spec. But if you look at the concrete block still has a minimum cement content of 320. If ministry could specify performance-based specs, we could greatly reduce the cement content. If we were all able to make these changes, we would make a significant impact on the environment.
This is another great example of the efforts the concrete industry is undertaking in British Columbia to reduce our environmental impact. Thanks for watching.